valid within the calibrated boundaries. Okay. So calibrated boundaries means what? If your model works between 80 degrees to 200 degrees, your model is perfect. If you operate at 400 degrees, that's where the model will collapse. Okay. So you can make any assumption. You can do some numerical methods if you want to predict the future or predict what's happening outside the boundary. You can do that also. So that is the disadvantage of empirical models. And this is one thing that as I said, chemical engineers are really good. Mechanical engineers and material science were really, really bad. So I hope those who are in mechanical engineers will adopt empirical models also. Okay, don't be like me. Okay, read the book, how to make beer. Up to now, I'm not make beer yet. Okay, so that is for empirical models. Okay, so the next one I want to talk about is the predictive model. Okay, so I'm going to wipe the board again. Can anyone tell me how's the economy doing now?
It was doing like crap last time I checked.
Yeah, when is the last time you checked your cheeky sword?
Like 2 weeks ago.
Yeah, it's challenging time. Okay, I mean, I'm almost 50. I never thought about anything like this could happen. I thought 2008 was the worst, right? But I've not seen anything like this before. Okay, it's so weird. The economy is so weird now. Everything. I mean, jobs is difficult. Everything is difficult. Stock market is just going up, coming down. Property price have not changed yet. Okay, that is the weird thing. You thought something like this happened, property price will collapse. No, property price is still stable. Any idea why? Anyone? Why property price is still stable? Anyone?
Donald Trump.
Hey?
Donald Trump.
Donald Trump. I like the answer. Okay, we'll talk about that later. Okay. So I put down there while I'm cleaning the board, we're going to talk about property. Okay. So I'm putting down here. So when I rub the board the next time, we talk about properties. Okay. So we are going to look at predictive model. Okay, we will look at predictive model. So predictive model is based on the physical phenomena of the process. So you have to understand the fundamental mechanics of it. Okay, so usually requires basic sciences. So basic science over here, I'm talking about physics, chemistry, biology, okay, and something else, and mathematics. Okay, so it requires this sort of feature for predictive model. Okay, so that's okay. So the advantage of this is it does not require experimental data. Okay, it does not require experimental data. and it also can work, can operate. Okay, can also operate okay, can also operate with wider operating boundaries. So like what I said earlier before, if your model, if an empirical model can only work within a fixed temperature, usually a predictive model have a wider range. If and only if it does not change its phase. Okay. So disadvantage, come on, chemical engineers, give me some disadvantages, please. Come on, anyone. Or anyone, give me, yep.
Wouldn't you need someone to have done the research ahead of time to like have the values that you need to look up in the book?
Yep. Okay, so one part of it is over simplified. Okay, so these models are usually oversimplified, not real world. So example, not real world is like 2D and not 3D. Examples like this, okay? So it's a 2D. Sorry, my pen is fading, okay? So that is a big disadvantage that for what we call our predictive model. So another disadvantage.
It's pretty slow.
Hey?
It's pretty slow. You need to do all the research before you do anything.
Yeah, it's also pretty slow, and yeah, right. And it also now slow. I have to be careful down there because now we have super fast computer, right? And the other bad thing is that it is complex. Okay, complex, fundamental. Okay, fundamental theories. No doubt the theories are simple, but it can be complex also to apply to the real world. So these are the bad things and the good stuff about predictive models. Okay, so the question what's next is when to use what. Okay, when to use what. Okay, when to use what is critical. Oh, by the way, I forgot to tell you guys, I will teach until 8 o'clock. Then so our lecture will start at 6:30. I'll go until 8. You take a 15 minutes break. And then 8:15 you come back. We go until 9 o'clock. Is that okay? Okay. And then if I rub the board too early, let me know. Okay, like Eugene, hold on. I will need to copy. I will let you copy. Okay. Right. So property price. So property price has not changed yet. Okay. And this is my conspiracy theory. Why property price have not changed yet. So a lot of people are applying for money given by the government. That's about $2,000. What money you call that? Anyone?
Stimulus.
Yeah, what is it called again?
Stimulus.
SERP or something like that, right?
ESB.
Right. So people are getting money, and oh God, someone has done something. Any idea? Anyone? What do you all see now?
Different people in the.
Just a list of the participants.
Yeah, just a list of
List of
the
the people on the call.
So do you see me now?
Yeah, we see you.
Yeah.
Okay,
Yeah.
good. Come on, don't.
Good.
Okay, you guys are messing around. You guys are enjoying it. So the government is giving people money. No doubt they have no job. This is to pay for their mortgage. Okay, so that's why the property price have not come down yet. So we wait for another 6 more months. Then we see what will happen. Why 6 more months? Because in a banking system, where you have a mortgage, you don't pay your mortgage for 6 months. After that, the banks are going to take back your money. The banks will take away your house, and then when they take the house, they sell the house at a different price. That's where you see market will start to react, and then stock market will start to, I'm sorry, the property prices will start to go down. Okay, right. So now, when do you use predictive model and when do you use reactive model? Anyone? This is important because what I'm going to teach you down here is predictive model. But with this predictive model that we're going to understand in manufacturing process, right? Without reactive model, it's worthless. Okay, that's why I'm driving deep into this concept. And those of you who are going to work next year will embrace it also. Any idea? When do you use predictive model and when do you use reactive model?
Does it depend on the information that we have?
Yes. So when? Give me a general one.
So when there's research done about whatever we're doing, so if there's research done on how to make beer already, then we can use predictive model to look into that.
Yep. Okay, you're absolutely right. So to go back another stage, you tend to use reactive model when during process optimization. Okay, when you're doing process optimization, you tend to rely on reactive models because predictive model we can't do that because it's oversimplified or too complex that we just are getting gibberish. Okay, so the predictive model is used for designing process. Okay, so two very different scenario when you need to apply predictive model and when you need to apply reactive model. I'll give you an example. Okay, a very simple example. We are going to look into a spring. Okay, we look at a spring mass damper system. Okay, and this is usually when I say spring mass damper system, you always relate this to second order differential equation. Okay, so a spring mass damper system, so basically is a system. There's a spring. Okay, so the spring is K, and then we have a damper, which is C, and then we have a mass. Okay, so this is our mass, and then this is our Y, and then we have a disturbance. The disturbance is P is equal to cos or P cos omega t. For example, okay, so it's a function over here. Don't worry, this is still manufacturing, okay? Don't like, what cost is this about? This is still so when you look at the fundamental equation, you have md squared y over dt squared plus by c dy by dt plus by ky, and this is equal to p cos omega t. Okay, so from here, yes.
Sorry to interrupt, Professor, but are these notes going to be posted afterwards or just the recording of the lecture?
I will post the whatever I've written, okay, on Avenue to Learn.
Okay, thank you.
Okay, but if you my encouragement is copy, okay, because if you sit down there and you just listen to me, you'll be bored. Okay, that's my advice because I listen to my own voice. Within 5 minutes, I'm sleeping already. I sound like shit. Okay, unfortunately. Okay, I don't have a voice like Celine Dion. Right. So now, what we tend to do with predictive model. Okay, so the predictive model, right? We are able to determine. Okay, determine K, C, and M. Okay, the predictive model is you are able to determine P, C, and M. Okay, so you design a system, what spring to use, what damper to use, and what mass to use. Okay, so from here, the predictive model is able to do this. So you can see that, right? So now this is time. This is y. Okay. So I know our disturbance is p cos omega t, but I will just put a value over here. So this is our desired value.